It's a diagnostic communication ISO standard, that is ISO DIS 14229. UDS is mainly used for vehicle diagnostics. So basically it works on a CAN protocol. So on top of CAN only UDS will work. So let's see what is a vehicle diagnostics. Let me explain with a simple example. So if there is any problem in your car, then what you will do, so you will take your vehicle to a garage. So after seeing, there will be warning light. After seeing warning light, there will be warning light displayed on the dashboard. So after seeing that warning light, then you will take your vehicle to the garage or service center. So then the service person connects the tester tool for finding the root cause of a problem in your car. So usually whenever the ECU finds a problem, it stores that problem as a DTC in the memory, that is in EEPROM for later retrieval. Tester tools are used to read data from the memory to find the root cause of the problem. So to communicate from tester tool to vehicle, we require a communication medium, that is nothing but a CAN protocol, which I discussed earlier. And there is a communication protocol required, that is nothing but UDS. So this is just overview. Let's go in detail. So there are different diagnostic protocols available, not only UDS. So let's see what is the KWP 2000. This is used for onboard diagnostics, that is for OBD. This is mainly used for self-diagnostics and self-reporting capabilities. And the next one is J1939. This is used for heavy-duty commercial vehicles. And the next is our UDS. It can be used for all the vehicles, and the most important point is, like, nowadays most of the vehicles we use UDS. Is the latest one also compared to remaining two. So next, UDS and CAN and OSA model. So as you know, there is a OSA model. So we can compare with this model how UDS works. So if you see, as you know, CAN protocol works in physical layer and data link layer. There is below two layers, data link and physical layer. And UDS works in application layer mostly. So to connect this CAN frames from UDS, there is a network layer in between. So required for converting this data to packets. For example, as you know, CAN supports only 8 bytes of data, but whereas UDS supports 4095 bytes. To route these 8 bytes and convert it into packets, so there is a network layer required here, that is nothing but CAN TP, that is ISO 15765. All these are ISO standard specific, like CAN protocol, the CAN TP and UDS, and all these are ISO standard specific protocols. Next, the basic principle, UDS works on request response communication principle. So that means if there is a tester, that means that there is a tester tool and ECU, as you see here, the client and server tool and ECU. First, the tester tool sends a request, and then ECU will respond with a positive or negative response. It depends on the situation. So there is a standard format for request and response. So there are different services available for different tasks to be done. So there are nearly 25 services available for different tasks to be done. So let's see a simple example here, simple request and response, how it will work, just to understand the basic functionality. So we are using RDBA service here. So RDBA is nothing but read data by identifier. So that service ID is 22 here, as you see here, 22. So this is the example request format that starts with service ID 22 here. So 22 and followed by DID. DID is nothing but data identifier. So this RDBA service is used to read particular parameter data from the any ECU. For example, if you are using any engine ECU, so we'll fetch particular parameter from the engine ECU. For example, if you want a vehicle speed, for example, suppose I want a vehicle speed from the vehicle. So we can read using service ID RDBA, read data by identifier, and this DID should be configured in the software. Then only we can able to read the data. So once the DID, that F123 example which I gave, that is used for reading vehicle speed. So that may be changed. But just for example, I gave F123. So that may be any DID that can be read, any parameter we can read. So in this example, if you see, the request is 22 F123 here. So and the response will be for positive response, there is a 40 added, the 22 plus 40, that is 62, followed by DID F123, that is unique ID which represents vehicle speed, and followed by 5678, that is nothing but the exact original data of the vehicle speed 5678. I just gave a example here. 5678 is the vehicle speed, for example. So tester tool connected, and we gave a request and we got a response. And the positive response not always the like guaranteed. For example, you'll if there is any problem, then you will get a negative response as well. So the negative response code will start with 7F and followed by service ID, and then followed by the negative response code. The negative response code here is 31, which represents, there is each every code there is a particular identification. For 31, the request out of range. That means the given request is, suppose if I gave 22 F124, for example, which is not defined in the software, then we will get negative response like this, 7F22 31. So I hope this basic concept is clear. To understand further, this is very important point. So this is just one service I explained. So there are nearly 25 services like this, and the frame formats may be different for each and every service. So next, if you see list of complete services, as I told, there are nearly 25 services, as you can see here. So in previous slide, we have seen only one service, that is our RDBA, read data by identifier service. So each service has a unique functionality to do, as I discussed. So all the 25 services mainly divided into 4 parts as given here. That is diagnostic and communication management functional unit, and the data transmission functional unit, and store data transmission functional unit, and upload download functional unit. So this diagnostic and communication management functional unit, there are some services it comes, like a diagnostic session control, ECU reset, test present, and so on. These are the basic functionalities required to handle UDS. And there is a data transmission, like you can read data, any data from the ECU, we can write any data into the ECU. Those functionality will come under data transmission functional unit. And there will be like DTC stuff. DTC stuff is nothing but diagnostic trouble codes. If there is any problem in the vehicle, that will be stored as a code, unique code DTC, in the EEPROM of the ECU. So this will be used for reading DTC and clearing diagnostic information, or DTC, and so on. And there will be upload download functional unit. This will be used for reprogramming concept. Reprogramming nothing but, suppose once you program the ECU, suppose next time if you want to upload a new software, that is possible using UDS. So only to the MCU. So the basic services, I will start with the diagnostic session control, the service ID. As I told, each and every service has a unique service ID. For this diagnostic session control, the SID is 10. So there are different diagnostic sessions available, like for example, default session, programming session, extended session, and EOL session. So this is the basic service in the UDS. So by default, after power up, the UC will be in default session. So suppose if you want to do any non-critical diagnostics, then this default session will be useful. For example, if you want to read any data, as I told earlier, like what is the vehicle speed, so that is not very critical data, so we can read it in a default session. By default, the ECU will be in default session. Suppose if you want to read from critical part of the diagnostic service data, for example, that will be allowed in non-default session. Non-default session is nothing but like extended session, programming session, and UL session. And UL session is a customer specific subfunction here. So it's not common for all. So the number will be changed, but remaining it should be as per the standard, like default session, extended session, and programming session. So the switching between sessions possible from any session to any. So that means if you are in default session currently, you may switch to extended session to do some operation or to get some service diagnostics. Suppose if you switch from default to extended session, so it will hold extended session for 5 seconds. There is S3 timeout. So there are some timing parameters we should follow according to the standard in UDS. So that is if you switch to default to extended, for example, that will be holded in 5 seconds. After 5 seconds, again, it will switch back to the default session automatically. So if you want to hold any session, then you have to send tester present. There is a separate service, which we are going to discuss in next slides. So that will be used to hold the session. So if you send a tester present service continuously after switching to any other session, that session will be holded. So let's see request response, positive response formats of this diagnostic session control 10. So as I told, for every service, there is a service ID. For this 10 service, the service ID is 10, and followed by there is a subfunction. So subfunction is nothing but here there are different subfunctions available, like default, programming, extended, and UIL. So as I told, UIL is a OEM specific. It not always the 40. In my current man-Hadient project, so the UIL session is 40. So remaining 3 are as per the standard we have to follow. Suppose let's see if for example, if you want to switch to extended session, for example, 10 03, you have to give request like this. Then the ECU will respond with positive response. For example, as I told, for this 40 added addition will be common for all the services. For 10, if you had 40, then 10 plus 40, it will be 50. Okay, and then next the subfunction will be like same. Suppose 1003 we are sending, the reply will be like 5003, like that, and followed by some timing parameters if you configure any timing parameters in the software. This is optional data. So as I told, not always the positive response is guaranteed. Suppose if there is any problem, for example, EC is busy, or suppose if there is a condition involved, or the given request format is not correct, then it will throw a NRC. So for example, there are 3 NRCs supported in this diagnostic session control. That is subfunction not supported, incorrect message length or invalid format, and conditions not correct. Suppose if you see 12 subfunction not supported, that means if you give 10, there are 4 possible here according to the software. Suppose if you give 10.05, for example, so that session is not valid. So immediately it will throw subfunction not supported. So there is a standard format for giving NRC as well. As I told earlier, it will start with 7F followed by service ID, that is 10, 7F, 10, and 12. So the format will be like this. So and incorrect message length or invalid format. For example, usually we have to give only 2 bytes, 10, 03 or 02, like that. So if we give 3 bytes, for example, 10, 01, 04, for example, that is the wrong format. So then the ECU will throw incorrect message length or invalid format. Suppose there sometimes there will be some conditions involved to read some data. For example, to read some vehicle speed. So first the ignition should be turned on. That's a basic condition. So after ignition on only the vehicle will move. So the vehicle speed increase. So in such conditions, if you want to read some try to read some condition based parameters, it will throw a conditions not correct parameter. So this one NRC 22. So I hope this is clear. I'm moving on. So next one is ECU Reset. This service is used to reset the ECU. That means there are mainly two types of resets in the ECU, like hard reset and soft reset. Hard reset will reset the ECU without holding any RAM data. So and that means after reset, it completely starts executing from scratch after reset. So whereas in soft reset, the contents of the RAM will be stored in a non-volatile memory, that is permanent memory, so that after restart, again the RAM contents will be restored during startup. So suppose if you want to hold any parameter before going to restart or reset the system, then that is possible using soft reset. So if you see the frame format of this reset 11th service, as I told, like every service has an ID, that is 11 here. So after 11, there will be sub function. Suppose if you want to give hard reset 1101, you will be giving. If you want to give soft reset 11, 03, you have to send. And then, so if you want to do only key off on, there is one more sub function available that will just do key off and on. It will not do any reset. So these are the mainly three sub functions available for this reset service. And the positive response, as I told, for everything we have to add 40. So 11 plus 40, 51, and followed by which request you give. For example, if you give hard reset, for example, 1101, here it will come like 5101. That is a positive response. And there are supported negative response codes, as I told earlier. So there may be sub function not supported, incorrect message length if you give invalid format, for example, and conditions not correct if the particular service is involved with some condition, then it will come like 22. And there is a security access denied. For example, a few OEMs, they don't want anybody to give reset without any authorized access, for example. In that case, then security access should be enabled. So to enable security access, there is a separate service for this, like then there is a seed key algorithm. There's a big algorithm for that. So we have to unlock the ECU first, then you have to send this reset, then only it is allowed. So without that, if you give, then it will throw security access denied, you are not authorized to give reset. So most of the OEMs will follow, that depends on their specification, they will follow. This is not. So next service is like tested present, like 3, the service ID is 3. So this service is used to indicate to the ECU that the tester is still connected to the vehicle. So that means that certain diagnostic services that has been previously activated are to be remain active. So if we send a tester present continuously, then the ECU will hold the current session. As I discussed earlier, suppose if you are switching session from default to extended, suppose you don't want to switch it back to automatically, as I told, automatically it will switch back to default session after 5 seconds. So if you don't want that, the switching automatically, then you, after switching to extended session, you have to send this tester present continuously. So if you send this test present continuously, then that particular session will be holded. So you can do your testing or you can do your diagnosis using tester. So for example, this may be applicable for security access timeouts as well. So that means if you unlock the ECU for security access, suppose if you don't want to, after 5 seconds, again the security access will be disabled. So if you don't want that disabling the security access, then still you can send this tester present. This will be used for not only for test, only for session switching. This is also used for security access as well. That's what I'm trying to say. So if you see the frame format for this positive response and negative response and request, then let's see the service ID is 3, so followed by sub function. Suppose if you, as I told, mostly this will be sent continuous, like once in 4 seconds we will be sending. Why? Because the timeout is 5 seconds. So if you send every once in 4 seconds, so the particular session will be holded. So this like periodically we will be sending this service. So 3 comma and 00, that is the request message format, and the positive response format is like 40, we have to add 3 plus 47e, followed by which sub function you give, 00 or 80. So 80, there's a meaning here. 00 means, suppose if you want positive response, then you have to give 00. So if you don't want any positive response, then you can send like 3 comma 80. Then you will not get any positive response. But the operation will be performed in the ECU. So this will be mainly used. There is a two things here, like physical addressing and functional addressing. So if you use functional addressing, that means, for example, in a vehicle there are more than 80 UCs available, for example. So in such situation, if you want to send only one tester present for all the 80 ECUs, in that case, if you expect positive response, how many positive response you will get? 80 positive response will come. So the CAN bus will overload. So to avoid such things, the single or like that functional address, we can send like one single ID, we can send like 380. You will not get positive response, but still the ECU holds the previous session. So I hope you understand the point. So and below are the supported negative response codes for this service tested present. That is 12 subfunction not supported. For example, 3 instead of 00 or 80, if you give 02, 3 comma 02, then it will throw subfunction not supported. And 3 comma, if you give 0102, for example, instead of 2 bytes, we are giving 3 bytes. So then it will throw incorrect message length or invalid format. So it will ask for you to send the correct format. Moving on. So next is read data by identifier. So this is mainly used to read data from the ECU. That may be any parameter from the ECU. So like for example, ECU identification data, like supplier data or VIN number or hardware number. So we can read any data in the ECU, which is stored in the EEPROM or which is stored in the currently there in the RAM memory as well. And engineering data like vehicle speed, lamp status, battery voltage, every parameter we can read using read data by identifier. So that means runtime data, all the parameter data we can able to read. Suppose if you want to engine temperature, for example, suppose the request will be 22, and if the engine temperature is associated with 1278, for example, there are 2 bytes of DID, 22 comma some 2 byte DID, then you will get engine temperature. So like that we can able to see in the example here. So there is a simple example here, so that I'm reading parameter, take like vehicle speed only, initially we discussed. So the service ID will be 22 and followed by 2 byte DID. So this is the request message format. So then you will get the positive response as I told, 22 plus 40 we have to add 62, followed by same F123, that is associated with vehicle speed in the software. So this is unique number for which represents vehicle speed in the software. So this should be configured before reading any data. This number may be changed for different parameters. And followed by the data bytes, original data bytes. For example, as I told earlier, 5678 is the vehicle speed. So the 2 byte data we can able to read one by one, and after one. So, and these are the supported negative response codes for this read data by identifier or DBA. So incorrect message length, as you know already this one. So if you give a incorrect length, it will throw this one, and conditions not correct. This also you know. And the request out of range. Suppose if the DID is not configured, for example, F144, for example, that is not configured in your ECU or software, then if you still try to read that, then it will throw this request out of range. And security access denied. If the DID is associated with some security, then you have to unlock the security access first, then only you can able to read the data, particular DID data. So next one is like write data by identifier. So the service ID is 2E. So this service is used to write some data, like for example, if you want to write any data to the ECU, into the ECU, then this will be useful. Usually the written data will be stored in EEPROM. So nowadays we are using external flash or EEPROM also. So mostly we use security access enabled to write data into the ECU using WDBA service. That means not this WDBA, some suppose if the data is critical, then we have to enable security access, then only we can able to write. So most of the OEMs, they will give security access for this service for writing data into the ECU. So just to avoid somebody try to write some data, invalid data, that can be avoided if you provide security. So as I told, like is like opposite to read data by identifier. Like we can read any, we can write using RDBA, you can read any data. Using WDBA, you can write any data into the EEPROM. That can be read using RDBA. Suppose if you write some data using the write data by identifier. So if you want to read, the same DID will be useful. For example, as I told, vehicle, suppose VIN number here. There is example here, VIN number. Suppose if you want to write some VIN number, suppose the DID is for VIN number, that DID is 1234. The same DID can be used for read data by identifier as well. So in many cases, mostly the will be stored in EEPROM or external flash. So these are the positive and negative response and request message formats for WDBA, write data by identifier. So the service ID is 2E, so and followed by F100. So this is just example to write some particular data. For example, F100 is VIN number I'm trying to write, or ECU programming data, for example, or installation data. Any data can be read. That data should be mapped with one DID in the software. Suppose if F100 is associated with programming date, for example, then that can be write using 2E comma F100 followed by what are the programming date. Suppose 1, 2, 3, 4, for example. Like any parameter we can write. It's just example. And the positive response will be, as I told, 2E plus 40, 6C, and followed by same DID. That's it. So the written data will not come here. So only 40 plus DID. That's it. That means your written data will be written into the ECU EEPROM memory or internal memory. So these are the supported negative response codes, like incorrect message length or invalid format. This is common for all, most of the things. Conditions not correct, common. Request out of range is also common. Security access denied, common. General programming failure. So this will be used during programming. We use this WDBA service. In that case, this NRC will come. Otherwise, normally it will throw any one of the above. Like for example, we can keep before writing data, we can keep some conditions. For example, if the ignition is on, then only you will write the data. Then that can be possible here. Or if the data is 0, suppose we are trying to write zeros instead of some valid data. That time also we can keep some conditions not correct here. Then in that case, it will throw conditions not correct. Moving on to read diagnostic trouble code information, that is RDTC. We call it as simply RDTC. The service ID is 19. So this service is used to read diagnostic trouble code stored in the EEPROM. Suppose if there is any failure in the system, then the DTC mechanism in the ECU will store a DTC for a particular problem. For example, if there is a temperature sensor failure in the vehicle, so there will be a corresponding DTC stored in the EEPROM for lateral retrieval. So not only for any sensor failure, if there is any actuator failure, or suppose if there is any checksum failure in the memory, we can raise an DTC. If there is any under voltage or over voltage, then we can raise a DTC. For any fault, we can raise one DTC. So that list should be given by the customer. So the request message format for this RDTC is like 19, comma subfunction. There is a subfunction involved here. So each subfunction has some data. For example, if you want to report number of DTC by status mask, suppose if there are how many number of DTCs available, then 19, 01, and mask, data mask, always the unique number will be there. In our project is 09. So 19, 01, 09. So if you give this one, then you will get how many DTCs available in the system. Suppose if you want to read complete DTCs report, for example, status, for example, whether it is set or healed, the DTC set or healed, then if you want that information, then you can read like 19, 02, 09. So if you give this request, then you will get a positive response. As I told, the positive response always same. So 19 plus 40, 59, followed by your subfunction 02, followed by how many DTCs available with status, whether it is set or healed. And there will be some negative response codes for this also. This is also common here. So most of the negative response common, except few things applicable for few service IDs. So once the DTC is set, then there will be another service to clear the diagnostic information. Suppose one DTC set, for example, a temperature sensor failure, and one DTC set for that. The vehicle went to a garage or service center. Then what the service person will do? So you will replace the temperature sensor. So with a new one, after replacing, what he has to do? He has to clear the earlier fault, that is DTC. So then only the fault will be cleared. So that can be done by the service person using UDS service request. So that is service ID is 14. So this can be like 14 we can service ID, and there will be positive or negative response for this. And not only DTC, all the information which are associated with this particular DTC can be erased. For example, how many counters, suppose if the DTC is raised 100 times, the counter values will be cleared. All relevant to particular DTC or some group of, there will be some group like powertrain, body, chassis. Suppose if you want to clear only powertrain, all engine DTCs will be cleared. If you clear the body, all the body relevant DTCs will be cleared. If you clear only the chassis, that is also possible. And particular specific also possible. For example, that there is a P code for this DTC 14. If you give that P code is a 3-byte length. So for example, 01, 02, 03 is for temperature sensor failure information. For example, here after replacing the temperature sensor 14 comma and 1 2 3 4 1 2 3, if you give, then particular DTC will be cleared from the memory. So it will not clear remaining things. So that is also possible here. Like customization is also possible. This is the request message format for this CDA, clear diagnostic information, that is 14, followed by, as I told, there are 3 bytes. So these 3 bytes represents the P code, that is nothing but DTC code. So if it is a powertrain, we call it as P code. If it is a body, we call it as B code, but generally we call it as a P code only, mostly. And the positive response will be like 14 plus 40 will be added, 54. So it is a positive response, and the supported negative response is common, as we discussed earlier.